Okay, this video is about end behavior of polynomial functions. It looks very complicated, but really there's only 4 rules. Today's objective: to determine end behavior of a polynomial by looking at the degree and leading coefficient of the equation. Okay, so there are 2 things that we're going to have to identify in order to determine the end behavior of a polynomial function. We need to know if the leading coefficient is positive or if the leading coefficient is negative. And then we also need to know whether the degree is odd or if the degree is even. By knowing those 2 things, we can determine which of the 4 rules to use. Okay, so let's start with a degree odd polynomial where the leading coefficient is positive. The degree odd polynomial has always has one end up, one end down. That would be for both of these. Anytime there is a degree odd polynomial, there's going to be one up and one down. Okay? And I've put these words here because this, I think, makes it just easier to understand instead of the technical words. If the leading coefficient is positive, then it'd be an increasing function. If the leading coefficient is negative, then it would be a decreasing function. Okay, so again, back here, back to the leading coefficient is positive and the degree is odd. That tells you that the function is going to negative infinity to the left and to positive infinity to the right. Again, that it's increasing. All right, so I'm just going to draw a very rough squiggle of what that looks like here. It's increasing, it's going to negative infinity to the left. It's going to do some squiggles in the between, and then it's going to go to positive infinity to the right. Okay? If the degree is odd and the leading coefficient is negative, that tells you it's decreasing. That means that the left end is going to be up, and we're going to do a squiggle in between, and then the right end is going to be down. And depending upon the complexity of the polynomial, there might be a few different ups and downs on the curves. But right now we're only talking about the end behavior. All right, if it is the 2 on the bottom are either both ends up or both ends down. Okay, so if the degree is even and the leading coefficient is positive, that means both ends up. Okay, so the left end is up, the right end is up, and then in between we've got some curves. If the degree is even and the leading coefficient is negative, that means both ends are down. So we've got left end down, right end down, and some squiggles in between. Okay, so that sums up the end behavior. These words that are at the tops of each of these 4 boxes are the algebraic way that you're supposed to write this. Now, on your next test, it'll say things like f of x approaches negative infinity to the left, and it will say positive infinity to the right. That's the way it's going to look on your upcoming Chapter 5B test. But I also want you to know that I think on the final exam, it said something like, oh, darn it. I hate that. On the final exam, let me go back to highlighter, it said something more like this. It says something to the fact as x approaches negative infinity. This is just the algebraic way of saying to the left. And this is just the algebraic way of saying to the right. So let's look at some problems. Describe the end behavior and the graph of the polynomial functions by completing these statements. Okay? So f of x does what as x approaches negative infinity? Remember, that means to the left. And f of x approaches what as x approaches positive infinity? That means to the right. Okay. All right, problem number 1. The leading coefficient is negative. And the degree is 3. 3 is an odd number. Okay, well, odd degrees have to be ends facing different directions, one up, one down. If it is negative coefficient, that means that it is decreasing. So that tells me that the left end has to be pointing up. So what I'm going to say is that it's going to positive infinity, f of x approaches positive infinity as x approaches negative infinity. Again, this means to the left. That means to the left. And f of x. All right, if it's going down, it's decreasing. Remember, it's decreasing. If it's going down, it's going to go to negative infinity to the right, okay? So how do we say to the right? We say as x approaches positive infinity. I know that the symbols look a little weird, but again, just keep in mind, we're talking about, are we going in the positive direction, or are we going into the negative direction? All right, like problem 2, all right? So I've got a degree, or let's start with the leading coefficient. The leading coefficient is positive 2, okay? So that's a positive leading coefficient. Okay, and the degree is 8, so that's an even degree. Okay, so an even degree tells you either the both ends are pointing up or both ends are pointing down. Since it is a positive leading coefficient, that means both ends are pointing up. Okay, so how do I say both ends are pointing up? I say that the function is going towards positive infinity to the left. That means as x goes to negative infinity. And that f of x is going to up. Okay, both ends are up. Positive infinity as x goes to positive infinity. That means to the right. As x goes to positive infinity means to the right. Okay, problem number 3. All right, here I have a leading coefficient that is positive and a degree that is odd. odd degrees mean that we've got one end up, one end down. Leading coefficient is positive, tells you that it is increasing. All right, let's think about what that means. The left end is got to be going from a low spot. So left end goes down. Well, how do you say that algebraically? You say f of x is going towards negative infinity to the left. Make sure this is a negative sign. Negative infinity to the left. To the left means as x approaches negative infinity. And to the right, it is going towards positive infinity because, again, this is increasing. F of x goes to positive infinity as x approaches positive infinity. This means to the right. Last one. Okay, so here we've got degree even, leading coefficient negative. Okay, degree even means both ends are facing the same direction. Are they up or are they down? They're both down because the leading coefficient is negative. Okay, so on the left, f of x is going down. That means to negative infinity. To the left means as x goes to negative infinity. Now we're going to talk about the right, f of x, both ends down, so this one's also going down to the right. That means as x approaches positive infinity. All right, guys, that's it. Again, it looks confusing, but it's easier than you think.